So again, to sketch these graphs, same thing as before. We're going to find all of our x-intercepts and our y-intercepts. Our y-intercept for part A, how do you find that? You make x equal to 0. If x is equal to 0, can you see that you're going to get -2? Because 1 to the power 4 is 1 times -2 is -2. The nice thing about both graphs A and B, they're already factored. So you don't have to use any of your factoring strategies. They're already factored. We can already see what our x-intercepts are. The x-intercepts are x equals -1 and x equals 2, since it's already factored. Can you see that your -1 has a multiplicity of 4, and 2 has a multiplicity of just 1. You look at how many times it appears. So because it's x plus 1 to the 4, it means x plus 1, x plus 1, x plus 1, x plus 1, 4 times. So that has a multiplicity of 4. And this one has a multiplicity of 1, because it only happens once. So as far as what does this graph look like, well, we'll draw our x-intercept at -1 and an x-intercept at 2. We know it has a y-intercept at -2. And now we have to say, what kind of graph is this, so that we can talk about its end behavior? It's going to be an x to the 5th graph. Can you see that? Because you're going to have the x plus 1 4 times. That will make an x to the 4 happen here, and you have another x here. Multiply that all together. You're going to get an x to the 5. And it's going to be a positive x to the 5th graph. So your graph will look like and act like a line starting at the bottom and ending. Because -1 has a multiplicity of 4, it's going to bounce. And because this one has a multiplicity of 1, it's going to go through but no bend. So we're going to start down here. We get to our first one, it bounces off of there, goes through there. You don't know how low it goes, and it goes straight through that one. This is our graph. This is as much as we need to show as far as the sketch goes. Again, you don't know how far it goes down here. You just sort of estimate it and draw a nice smooth curve through everything. Yes? Not necessarily. Okay? So this looks like an x cubed graph, but an x to the 5 graph can look like an x cubed graph. Just like an x to the 4 by itself looks very much like a parabola. But an x to the 5 graph has the possibility of having more loops in there. Yes?
Would you lose points if you went from the -2 straight to the 2 and didn't have the other round?
No, if you decided that this was the smallest one and you bumped it there, you don't know how low that valley goes.
That would be okay?
That would be fine.
Okay.
So we don't know how low this goes, and we only find that out next year when we do calculus. Well, the next one's going to have a multiplicity of 3. So we're going to look at this one next. Let's get a new page for this. So let's look at part B. Again, your y-intercept here. Plug in 0 for x. You're going to get negative bracket 1 to the power 3 and then -3. Multiply that all out. This is where you're going to make your mistake, is in figuring out your positives and your negatives. This is going to equal to +3. Your x-intercepts, easy to find because it's already factored. X equals -1. and x equals 3. This one has a multiplicity of 3. What does that mean it's going to do? It's going to go through and bend. This one has a multiplicity of 1. That means it's just going to go through, no bend. What kind of graph is this? What kind of polynomial is this? It's going to be an x to the 4, a positive 1 or a negative 1? It's going to be a negative x to the 4. Because you have 1x here, and this one will be 3x's, and you've got a negative out in front. So as far as our graph goes, got an x-intercept at 3, an x-intercept at negative 1, y-intercept at 3. Because it's acting like a negative x to the 4 graph, this is what it has to look like. So it's going to start down here. When it gets to negative 1, it's going to bend. And then it's got to go through our y-intercept. And then where that maximum is, it doesn't matter. Just try to draw a smooth curve. You should have no sharp lines in your curve anywhere. So that's how the multiplicity works. So the way that we're going to sketch things is we're going to try and find out where are our x-intercepts and our y-intercepts. Factoring is going to be able to help us find that. Sometimes they'll be pre-factored like these ones. Once you're done factoring, you're going to look at the multiplicity to figure out at these x-intercepts, are there going to be bounces? Are there going to be bends? What's it going to look like? And then from there, you can sketch the graph. So I'm going to give you the questions, and then I'm going to make one up for you. 9, 10, 11, and 12. And I want you to graph on a scrap paper or anywhere where you have space. Yes. Oh, this is going to have one nasty y-intercept. Sorry about that. Enjoy. So let's go back to the factored form. Someone figured out the y-intercept already? Negative 6,144. Perfect. Your x-intercepts. Negative 1, 2, 4, and negative 6. So as far as graphing this goes, I would say maybe a scale of 1 is nice along the x-axis. Negative 1. We're going to have 2, 3, 4, 5, 6, negative 6, negative 1, 1, 2, 2, 3, 4. Those are your x-intercepts. Your y-intercept, I would say maybe a scale of negative 6,144 would be a good scale to use on your y-axis, because then it'll match up perfectly. And what does this graph act like? How many x's do you have? X to the 10. And it's going to be negative. I mean, we could have seen that from the expanded form too, right? There's that negative x to the 10. But if you added all them up, here you're going to have x cubed, here you have x squared, here you have x to the 4, here you have an x. That makes x to the 10. And it's a negative x to the 10, so it's going to act like a parabola. So as far as drawing your graph, you're going to come from down here. You're going to go, oh, we have to decide what we're going to do at each of these. I'm going to erase that for a second. What's going to happen at -1? Bounce, bend, or go through? -1 is it's going to have a bend. At 2, because it's a multiplicity of 2, it's going to have a bounce. At 4, another bounce. Woo! And at -6, it's going to go through. So, with that in mind, starting at -6, it just has to go through. So we just come down from here, go through. Then at -1, we have to have a bend. The bend goes through. It's got to go through our y-intercept. At 2, it's going to bounce. Boop. At 4, it's going to bounce again. Boop. And end down there. And that's our graph. Very cool.